Let's work some more with counting and probability. A combination lock has 4 wheels, each labeled with the 10 digits from 0 to 9. A little side note, a combination lock, like we know it, is really a permutation lock because the order actually does matter when we put these numbers into the lock. How many 4-digit opening combinations are possible if no digit is repeated? We can look at this in 2 different ways. We can use the multiplication axiom and say the first wheel we would have 10 digits to choose, the second wheel we would have 9, the third wheel we would have 8, and the fourth wheel we would have 7 digits to choose from. We are not repeating any digits. This is also a permutation. When we arrange things, we're taking 10 objects, arranging them 4 at a time. So this is a permutation. And reiterating this factorial by hand so that you can see that they're the same. Remember that for permutations we do n factorial over n minus r factorial. So 10 minus 4 factorial, that's really 6 factorial. So I'll write 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. And you can see that we would cancel the 6 factorials, and we're left with 10 times 9 times 8 times 7, which is exactly what we did with our multiplication rule. All right, multiply this out. Calculator, Excel, Google, however you want to do it, we would get 5,040 different combinations. How many 4-digit opening combinations if the digits can be the same? So this time our 4 numbers, we could have repeats, so we have 10 choices for each dial. This is 10 to the 4th, which would be 10,000. And then our last situation, how many if successive digits must be different? So I would have 10 choices for the first wheel. I pick a number for the first wheel. Then I have 9 to choose for the second wheel. Since it says successive digits must be different, in this third wheel, I could have the same number as the first wheel. That's okay. I just can't have the same as the previous one. So I can't have the previous one, which means I still have 9 choices. And by the same logic, in the fourth wheel, I have 9 choices. So we can think about it this way. If I choose the first digit to be 4, the next digit cannot be 4. It can be any other number, 0, 1, 2, 3, 5, 6, 7, 8, 9. But it can't be 4. So let's pick 8. The third digit can't be 8. It can be any other number. It just cannot be 8. So this third digit could be 4. It just can't be 8. What if it is 4? Let's say it's 4. Then the fourth digit can't be 4. Any other number, just not 4. So each one of these last 3 wheels, we have 9 choices because we cannot choose the number that was right before. If we multiply these together, 10 times 9 times 9 times 9, we get 7,290. Now, let's do a little thought experiment and put this into probabilities. So here's a bonus question. What are the probabilities for each of these of guessing the right combination? So what's the probability we guess the right combination? Okay, so for this first one, the probability of a correct guess, when we're talking about a lock, there's only one correct combination. So we have one correct combination out of 5,040 different possibilities. And if we divide we get that strange number with the e to the negative something at the end? Well, this is scientific notation. So 1.984, etc., e to the minus 4. So I'm going to write that down over here. 1.984 e negative 4. There's other numbers in there, but we don't need that many. This is scientific notation. The e is times 10. The negative 4 is the exponent on the 10. All this means is this 1.984, we're going to take that decimal place and move it 4 places. 1, 2, 3, 4. Fill in some zeros. And this is the actual number we have, 0.0001984. Recall, in probability, if we have a really small probability like this, we're going to round to the first non-zero digit. So we have a 1 here, we look to the right, 9 means we're really close to that next number. So we would round this as 0.0002. 2 10,000ths of a chance of guessing the right combination if we are not allowed to repeat digits. We can do the same thing for the next problem. If the digits can be the same, we have one choice out of 10,000, which will be 0.0001 if we divide on our calculators. And we can repeat for the next one, 1 over 7,290. And we'll get a number between these two. But that's the idea. When we're talking about probabilities, how many possibilities do we have what we want, a correct combination, out of how many total possible combinations there are? Generally speaking, if we're talking about any generic lock like this one, we have 10,000 different possibilities. So the probability of guessing correctly would be 1 out of 10,000.